Okay, so these first pair of examples in think, pair, share, this was kind of like a single step trig identity simplification. But often, these trig expressions take multiple steps. Okay, so they get a little harder. So let's look at an example of what one of those looks like. So we have this example here where it says simplify the following expression using established identities. So what we're trying to simplify is this complex fraction, compound fraction. So, we've got this numerator, which itself is two fractions being added together. And then down here in the denominator, we have a fraction. So we're just tasked with simplify that, reduce it down. So, you might look at this sine over cosine, cosine over sine, and come back over here to your trig identities and, realize, well, actually, here's sine over cosine, that's tangent, and here's cosine over sine, oops, and that's cotangent. Maybe I can use it over here. So maybe this is tangent plus cotangent. All right, that might work. In which case, this is a trial and error process. So plug that in and give that a shot. Um, so you convert this to tangent, you convert that to cotangent, but what do you do with this in the denominator? It doesn't really, not much is really going to happen with that. So what I would do instead is just something to try is let's try and simplify this compound fraction by getting what's in the denominator out of the denominator. Let's try and simplify this whole thing a little bit. So to do that, we could just multiply numerator and denominator by the reciprocal of the denominator. Okay, so what we would do is we'd multiply the denominator by the reciprocal of the denominator. So this is going to be sine theta cosine theta over 1. And we're going to do the same thing up here in the numerator. Sine theta cosine theta over 1. So you can see that this new expression that I'm multiplying by, that just is that that's just 1, the number 1, because numerator and denominator will cancel. Okay. So I'm kind of multiplying my original messy expression by 1. So that's an algebraic trick I can use. Well, the sine cosine theta here cancels with the sine cosine theta there. And so this is all that I'm left with. Okay. And that's what you see here in this step, right? You have this original numerator here being multiplied by that reciprocal of the denominator there. Okay. And the identity I used was division of fractions. So that was the justification to go from that initial step to this first step. All right. Now, we want to use the distributive property. So we want to take sine theta cosine theta and distribute this to each term in the parentheses group. So you can see here, we've got sine theta cosine theta. So here's sine theta cosine theta, and that's being multiplied by this sine theta cosine theta on the outside of the parentheses. And then the second term in the parentheses, which was cosine sine, here's cosine sine, and you can see that too has been multiplied by this sine theta cosine theta. All right, Well, what do you gain, by doing that? Well, if we look at this term right here, you'll notice that cosine theta now cancels with cosine theta. So we no longer have a denominator. We've been able to cancel the denominator with a like term in the numerator. And also in this other fraction, sine theta will cancel with sine theta. And so what do we have left in the term on the left? We have sine theta times sine theta, which reduces to sine squared theta. And then we've got cosine theta times cosine theta, which is cosine squared theta. And you remember our Pythagorean identity? Cosine squared theta plus sine squared theta equals 1. Well, sine squared theta plus cosine squared theta equals 1. So this original mess, that we had here at the beginning, this original mess here, all of that reduces down to 1. And we did that, by using division by fractions, the distributive property, and finally the Pythagorean theorem. So this is more of a multi-step trig identity simplification. All right. So use this example as a model and try and see if you can simplify this one on your own. Pause the video now and give it a try. Okay, we're back. So what we can do with this one is you'll notice that we have two fractions here and here. Okay, but these two fractions are without a common denominator. So if we could get them so they both have a common denominator, we could add them together. And that might be a route to simplifying this. So in order to make that happen, we're going to have to multiply this sine theta by sine theta over sine theta. And that's going to be plus our original term of cosine squared theta sine theta. Okay, well, now I have a common denominator and also recognize that now we've got sine theta times sine theta. So that's going to become sine squared theta plus cosine squared theta all over sine theta. And then we can use the Pythagorean identity of cosine squared theta plus sine squared theta equaling 1. So everything here in the numerator is going to be equal to 1. And what's 1 over sine theta equal to? Cosecant theta. So this whole expression at the beginning simplifies down to just cosecant theta. All right. Let's see here, cosecant theta. I think if we go back, yeah. So you can see right here, cosecant theta is equal to 1 over sine theta. So you might have had to refer to this sheet, or if you just remembered the definition of cosecant. It's the reciprocal of sine. Okay. So that's those two examples. Let me know if you have any questions.